Alright, today we're going to do number 2 from Unit 5. The question reads, the total charge that is passed in a given cross-section of wire varies with time according to the relation QT is equal to Q naught 1 minus E to the negative T over B. And then it gives us starting values, but for the first part we don't need them. Find the current in the wire as a function of time. So you're trying to find I over Q over T, and then one can see that dQ over T would yield the same results. So if you take the derivative of this, Q0 is a constant, 1 dies out, and then you take the derivative of this, and then since negative 1 over B is a constant, that comes out front. So you get negative from here, cancels with your other negative 1 over B, and then you have E to the negative T over B still. And then just moving around to the way they want it, Q naught over B, and it's actually a capital B, not a lowercase b, E to the negative T over B. And that is I as a function of T. Then B, what is the ratio of the current at 1 second to the current at 0 seconds? So I1 over I0. Notice that this is a constant that's given, this is a constant that's given, and B is also a constant that's given. So E over negative T subscript 1, E to the negative T subscript 0. If you put this in, E negative 1 over E to the 0 is going to be 1. So then you have 1 over E, which is equal to 0.367879. That's quickly equal to. Then lastly, it says draw the graph of the function. So this is I, and that's in charge as charge over time, and this is time in seconds. You're going to start off at your max value of 0, and they've given that Q naught is equal to 30 microcoulombs and B is equal to 1 second. So knowing that the max value, if you plug it in, you're going to get 30 microcoulombs a second here, and that's going to be your max value since you can't have negative time. T equals 1 is going to be around 11.03 if you plug that in. T equals 2 is going to be 4.06, and then it's just going to decrease and never really hit 1. And this is an asymptote.